Hi guys, this is the first of a series of videos that I'm going to post up on our Google Classroom site, and this video is all about estimation, so feel free to watch it as many times as you would like, to pause it, to rewind it, and even fast forward it if you feel like you are good to go with something, okay? All right, so I'll start with estimation. This is for the first part of a two-part video, and this one is about overestimation and underestimation. It's one of the strategies that you can use to help you get a quick answer when you're working with fraction problems, okay? So I've drawn a target here because estimation is kind of like trying to get as close as you possibly can to the actual answer, okay? So it's sort of like an educated guess, okay? Where the target, the very center, is the actual answer. And as you move farther and farther out, you're getting a little bit further away from the actual answer, but you're still kind of in the ballpark. You're still in the right area, so you're getting close. So you might ask yourselves, Mr. Carpenter, I already know how to multiply fractions. I'm good to go. Why do I need to know how to use estimation? Well, estimation is something that you can use to quickly check your answers. I know a lot of you guys spend a lot of time working out math problems, especially word problems. And what I see a lot of times is you'll have little teeny tiny math errors and you won't even catch it. You'll think you're all done. You think you're good to go. And you turn in your test, and guess what happens? You're way off. Now, if you had stopped and you had done a quick estimation strategy, you could have seen real quickly, oh man, I was not on the right track there. Okay? And these strategies, they don't take that long. They really don't. They're just a few brief seconds, and then, oh, look, here is a possible answer that I could get. They give you a ballpark answer, a rough idea of where the actual answer is, okay? So that's kind of why we use estimation. So now let's learn a little bit more how to do it, okay? So again, the strategy I'm teaching you is overestimation and underestimation, all right? So I've drawn a little line here, and at the base is the smallest possible number that the answer could be, okay? And at the other end of the line, at the other end of this arrow, is the biggest possible number that the answer could be, okay? Now, our actual answer is somewhere here. It's somewhere in the middle here. We're not exactly sure where, but our estimate is going to give us, okay, well, this is the smallest it could be. If I get smaller than this, I know, whoa, I'm not on the right track. If I get bigger than this number, whoa, I'm not on the right track. This is called our range. This is the possibilities or the possible numbers that our answer could be. Okay, this is our range. So now we're going to talk about how do we use overestimation and underestimation to find out our range. Well, I'll teach you a strategy right now. All right, and down here, you're going to see a pretty simple fractions problem. Most of you guys can solve it without using any estimation strategies. But again, remember, we're using estimation as a quick way to check, okay, am I on the right track? All right, so here we go. We have 3/4 times 3. Okay, well, here's the problem, the 3/4 part. It's a little difficult to work with fractions sometimes. I can't remember. Do I multiply only the numerators? Do I multiply the denominator? Oh my gosh, I have no idea what to do. Help me. Well, estimation is a quick way to help you out and say, look, I'm on the right track, or I'm not on the right track. It's kind of like a safety net. All right, so here's what we can do. We're going to go ahead and we're going to underestimate. We're going to find out what the smallest possible number that this answer could be, 3 times 3/4. Okay, so what we're going to do is we're going to round this 3/4 down to the lowest possible number it could be. All right, and to help myself do this, what I'm going to go ahead and do is I'm going to represent this as a picture. Remember, representing things as pictures is one way that mathematicians simplify problems and make them easier to solve. Okay, so I went ahead and I drew a box and I divided it into fourths because we're talking about fourths here. We're talking about 4 pieces total, okay? Now, if I were to have none of these shaded in, or another way to say this is I have nothing, that's equal to 0 fourths, or another way to say 0 fourths is 0. So to underestimate, to round this to the lowest, smallest possible fraction this could become, is it's going to become 0. Okay, so what we can do is we can, instead of working with this really hard number here, this fraction, we can go ahead and round it to a whole number, okay? And our lowest possibility is 0. It couldn't be negative, okay? Because, well, we don't have any negatives here. We're talking about fourths here, okay? All right, so we're gonna go ahead and round this to 0, okay? And as you can see right down here, I've written a smallest number sentence. So I'm going to go ahead and plug in my lowest estimate. So now I have 0 times 3. Oh, well, that's easy. 0 times any number is equal to 0. 0 times any number is equal to 0. So we're going to go ahead and say that our lowest possibility, the lowest number that this answer could be, the smallest number, is 0. So I'm going to go ahead, go back up to my range chart, and I'm going to fill that in here. 0. 0 is the smallest number that this answer could be, okay? Well, now let's talk about our biggest number. What is the biggest answer that this could be? Well, let's go ahead and shade this in. We know we have 3 fourths, so I'm going to go ahead and shade that in. All right, well, again, we're working with fractions here, and fractions are sometimes hard to deal with. So what I'm going to do is I'm going to round this to the nearest whole number. The nearest whole number. Well, 3 fourths. That's awfully close to, yeah, it's close to 1 whole, right? So we can think of 3 fourths, our biggest possible answer, the biggest thing that we could get when we're multiplying, is this is close to 1, okay? So the next number up, the next highest number that we could round to would be a 1. So again, I'm going to go over here. Now, do you see how I wrote 2 of these down? And again, this is the smallest possible answer, and this is the biggest possible answer. Well, we rounded our 3 fourths to 1. 1 times 3 is equal to 3 because of the identity property of multiplication. Any number times 1 is itself, okay? All right, so I'm going to go ahead and fill that into our range. We know that our answer, our actual answer when we do the multiplication, it's going to be somewhere between 0 and 3, okay? All right, so what I'm going to do now is I'm going to give you a couple of practice problems that you can work on, and you are welcome to review the video, pause the video, do whatever you need to do, but here are the problems. So the first one is 3 times 1 and 1/2. So ask yourselves, what is that going to round to if we are underestimating or overestimating? This one is 5 times 3 and 3/5. Again, look what we've got here, 3 and 3/5. Is that going to round down to 1? I don't think so. That's a little bit too low. But look at your fraction here. How's that going to affect the 3? Okay. Again, we've got, oh, now look down here, 3 fourths times 4 1/8. Now we're dealing with 2 fractions. How are those going to change? Okay? All right, so hopefully you know a little bit more about overestimation as a strategy. All right, the next video you're welcome to watch is all about compatible numbers.